Hello students, welcome back. In today's video, I'm going to calculate the expectation values for some operators for harmonic oscillator wave function, and this can be done very easily using ladder operators. So let us calculate. So we know the ladder operator, rising operator is given by 2m h cut omega m x cap minus iota p cap, and a minus is given by 1 upon 2 m h cut omega m omega x cap plus iota p cap. Now suppose if I want to calculate the x cap, so if I sum a plus a minus, then this will give me 2m h cut omega. If you sum this one, this will give me 2m omega x cap iota p will be cancelled out. So this gives me 2. So this will be root 2 m omega h cut x cap, and this is a minus, or you simply write a. So this gives me the x cap value as under root h cut upon 2m omega a rising plus a annihilation operator. So this is my operator x value. So h cut 2m omega a plus a. Now let us calculate similarly the p value, operator p. So if I subtract now say a bar, a rising minus a, so what will come? It will come 2m h cut omega, and this will be remain minus 2 iota p, and this gives me root minus iota root 2 m h cut omega p cap, and p cap will become your 1 upon, this is the minus will go here, 1 upon iota minus m h cut omega upon 2 a minus a. Now minus 1 is iota square, so this will give me iota m h cut upon 2 a plus minus a. So this is the operator p value. Okay, now let us calculate the expectation values. So if I want to find say x, expectation value of x, so this will be simply under root h cut 2m omega, say x is what? X is your a plus a, this is my x. Now expectation value will be x in the state n x cap n, and this will be giving me h cut upon 2m omega n a plus a n, and this is obviously, this will modify this state n, so this will be always 0. Okay, similarly we can tell the operator value of p is also 0, because this will be a minus a bar. So now we can, so whenever so this result we can generalize for the odd power. So whenever there is a x cube, x5 or p PQ, P5 expectation value, those all will come 0. Why? Because you have a harmonic oscillator has a uh, even symmetric potential. So this is a symmetric potential. Harmonic oscillator potential is symmetric. And whenever you have this symmetric potential, your wave function has a definite parity. So if I calculate, say x power n, where n is odd, then this is equal to psi star psi x power n psi dx minus infinite to infinite. Now this can be written as a minus infinite x power n psi x square psi n dx. Now this is always a even function. It's a function with even parity. Mod psi x is always even function because whenever you have potential symmetric, psi can be either even or odd. So if it is even, then the mod is also even, mod is also even, and if it is odd function, then also mod square will become even. Okay, suppose you have a function, say something like this, psi, which is exactly odd function. When you take the square, that become even function. So psi, this is always a even function. When you multiply with an odd parity operator like x p x cube p cube, what will happen? This function become odd, and when you integrate this one, integration will give you 0. Okay, similarly p, here p is a uh, negative parity operator. Negative parity operator means odd parity operator. P is what? Odd parity operator. Odd parity operator. Or odd parity operator, what means? Whenever P operates on psi, if psi is even, P psi become odd. And if psi is even, this become odd. And similarly, if psi is odd, then P psi becomes even. If psi even, P psi becomes odd. So what will happen? If this is odd, this become even, odd, even, odd. Similarly, if it is a odd, this become even, odd, even, odd. So this will always 0. So the odd values of operator x cube, this will be all 0. So I can write xn is equal to 0, pn is equal to 0 when n is odd. Okay. Now let us calculate for even values of n. Let us calculate for x square. Expectation value of x square. So expectation value of x square will be n x square n, which is now what I can write. X square can be written as h cut upon 2 m omega a plus a and a plus a. So now I can write this is h cut upon 2 m omega. If I multiply this one, this will give me a plus a square and plus a square, and then you got a dagger a and a dagger a. So this is h cut upon 2 m omega plus a square. Now let us write this because we know the commutation relation. A bar is 1, so a bar minus a bar a is equal to 1. And now I want to write the value of this one. So the value of this one will be a will be 1 plus a bar a. So this become 2 a bar a and plus 1. So now just calculate the values. So when this operates on n, this will change the n indices. So this value will be 0, this will be 0. Only we have to operate in order to calculate x square. We need to operate 2a, this is a number operator, plus 1 on n, because when you operate this one, this will change the n. Similarly, this will also change the n. So overall, this will become 0. So now they are, whenever they are equal numbers, then only you get some values. So I can operate. So this will give you, of course, this is there, h cut upon 2m omega, h cut upon 2m omega. Value will be now, if you do it like this now, this will give you 2n plus 1. So when a operates number operators, you get n, so 2n plus 1. So this is the expectation value of x square. Similarly, you can do it for p square also. If you do it for p square, so what we can write p square we can write minus m h cut omega. The root will be cancelled. Root will be now simply m iota square minus 1 m h cut upon 2, and now you have a minus a minus a, and this can be written as a m h cut omega 2. If I solve this one, this will become a square, and minus minus plus a square. This is give you minus a bar a and minus a bar, and this can be written as a minus h cut upon 2 a square a square. Again, this is a minus a, and this is can be written as a 1 minus 1 plus a bar a. And if you solve this one, minus m cut omega, this will give you a square now minus 2a and minus 1. Okay, so similarly same, if you calculate now expectation value p square, these terms are not useful for us. Okay, only we use these terms, and if you take minus common, so this become m h cut omega 2 and 2a bar a plus 1, and the similar type of expression will come, only constant difference. So this will come your 2n plus 1. So this is the expectation value of p square. Now let us calculate one more. You want to calculate for x4 also. Okay, let us do it for x4 now, x4 also. So say x4. Now x4, how can I write x4? Say x4 I can write as x square, and I can write this as a, I can multiply this by summation m is equal to 0 to m is equal to infinite x square, because we know the sum of projection operators is always equal to 1, so I can always multiply with by 1. So this is becomes this one, and now if I calculate the expectation value of x4, what it will give me? It will give me, you operate here, this will go here, so this will give me summation m0 m n x4 x square m, this term multiply here, similarly this multiply here. So now this will give me m multiply x square multiply n, and this is equal to m0 m infinite. This you can write, this is the complex conjugate or adjoint of this one, so you can write this is the m x square and mod square. So we need to calculate this here, okay, and the non-zero value. So this expression will be because here x square is there, so x square means if I want to calculate, so here either m can be n minus 2 or n plus 2. In those cases, or n or equal to n, in that cases only you'll get the value of this element. Otherwise every element will be 0. So I need to only calculate for m equal to n, m equal to n plus 1, n plus 2, and m equal to n minus 2 for this expression. So let us calculate these expressions. So I want to calculate first say n x square n, which we have already calculated. It was came h cross upon 2m omega 2n plus 1. Now let us calculate n plus n minus 2 x square n, which is equal to n minus 2 x square. X square we already written, this is the a plus square a square plus 2a plus 1 n. And now when this is n minus 2, only this term is important. So this become n minus 2. These all terms will give you 0. A square n, and a operates. Of course, there is this constant is coming here. So this constant will come h cut upon 2m omega. And when a operated 2 times here, you get under root n, and then you got under root n minus 1. So this you get n minus 1. Similarly, when you calculate n plus 2 x square n, you only use this raising operator, okay? So n plus 2 only will use raising operator, all other terms will become 0. So I can write this as a constant is running here, h cut upon 2m omega, and this will give you n plus 1, n plus 2. So my final answer n x4 n will be mod of this square. That means h cut square to 4 m square omega square, and square of 2n plus 1, square of n minus 1, and square of n plus 1, root n plus 1, n plus 2. And if I solve this one, h cut square 4m square omega square, which is 4n square plus 4n plus 1 n square minus n, and then you have a n square plus 2n 3n, and then you have a 2. So if I solve this one, this gives me h cut square 4m square omega square 6n square plus 6n and plus 3. So if I take 3 common, so this gives me 3 h cut square 4 m square omega square 2n square plus 2n plus 1. So this is my expectation values, the expectation value final answer is correct. Let me check the answer. Yes, this is the correct answer. So we have x4 is equal to 3 h cut square 4 m square omega square, and then you have 2n square plus 2n plus 1. Now you can calculate P4 also similar way. If I want to calculate P4, okay, so P4 constant, only there will be difference of constant. You'll get now 3 m square uh, h cut square omega square and 4, and this expression remains same 2n plus 2n plus 1. So these are the expectation values. Okay, you can check it. So let us meet with next video where I will calculate the expectation values for coherent states. Okay, thank you very much.